Hello,
Hey everyone.
everyone. Nice to see you. We're just having some technical issues, but thank you for waiting. Right, let's get started. So thanks everyone for joining the webinar today. Conduktor 2.0, so the new standard for teams working with Apache Kafka. Looking forward to showing everybody what we're up to. It was great to see a lot of you at the Kafka Summit last week. So let's get on with it, and feel free to let us know where you're tuning in from in the chat. If you've not joined a webinar before on Livestorm, you have options here to react and engage. Feel free to ask questions throughout the webinar. We'll either choose to answer them on the spot or we'll come back to them at the end and we'll revisit them. So I'm very delighted to be joined by our CPTO, Stefan, today. So Stefan, do you want to introduce yourself?
Hi guys, so I'm not taking the stage often, but today this is it. So Stefan, I've co-founded Conduktor a few years back. Good stuff, product has evolved a lot, and we are going to see that in a few seconds as well. And yeah, let's talk about Kafka. Do not hesitate to send questions and to emoji stuff. Let's make it fun, okay?
Awesome. We are both in London in separate rooms.
Yes.
Okay, and I'm James. If you've joined a webinar before, you likely will have seen me. I'm Director of Product here. So let's move on. So what are we going to focus on today? So we're going to get into Conduktor 2.0, but to enable us to get there, we're going to first kind of reiterate the landscape today, why Kafka has won, have a look at some of the issues that are still slowing us down with this technology, and then look at how we can accelerate, which will segue us into Conduktor 2.0. If you were at the Kafka Summit last week, there was, of course, a raffle to win a Nintendo Switch. If you've joined solely for that reason today, I'm sorry that we've put that at the end, but we will do the raffle live. So if you did enter that and you have a chance of winning, we will announce that towards the end. So if you don't know Conduktor, essentially we're building tooling to enable platform teams to introduce standards, introduce processes, and also introduce a more flexible and autonomous way of working for software developers. We've been used by over 15,000 companies to date and used by over 100,000 developers. We are vendor agnostic, meaning that we support all Kafka flavors, regardless of whether you're using a cloud, managed service provider, or you're self-hosting Kafka as well. Conduktor, all of Conduktor's products supports all of those varieties. And what we're doing is we're building a collaborative Kafka development platform. So if you're not familiar with the specifics of the platform, we essentially have our console, which is the mechanism to give developers visibility into Kafka cluster, all of the underlying resources. And then we're also building our Kafka proxy, which is AKA Conduktor Gateway. Now, this is something that sits between your applications and your backend Kafka cluster. We will speak about that in a bit more detail later, so I won't dwell on that too much right now. We're used by all businesses that are using Kafka for their critical operations, and we are working with our trusted partners as well. So hello to those guys that are on the webinar today. If you want to maximize your Kafka and your Conduktor impact, then we recommend working with one of these guys as well. So on to the subject of today. So data exchange at scale. Let's just quickly recap why Kafka won. So Stefan, over to you.
Yeah, so let's talk a bit about Kafka, obviously. Why Kafka win? It's a bit of a controversial title, obviously. It's to create discussion. But if you are not aware, 80% of the Fortune 100 is actually using Kafka, so for good reason. So in the world, it's just massive. Why? If we think about, why Kafka is like, yeah, it's a very beautiful, technology to send data and to read data. So this is the bottom part of this slide is technology is just amazing. It enables things that were not possible before. And this is a beautiful thing. We have a very large community of people helping each other. We have a large ecosystem of integration tooling. Kafka is beautiful, but you need obviously to integrate Kafka in your existing ecosystem, especially in an enterprise where we have so many systems, and Kafka is just, I think, compatible with everything in the world. It's why it's kind of successful. The other reason is beyond technology, is the separation of concern. It means that Kafka, before you were supposed to own all the data and to be aware of all the data, who is using what, when, how. Kafka allows you to just produce data, and you do not care of who is consuming your data. And when you consume data, you do not care who is producing the data. So it helps us from an organizational level to think just about the minimum footprint that we need to know to work with data. And the last thing is, thanks to this, we can scale as an organization, and we can resolve a lot of business use cases. Most of them are critical: fraud detection, payment, customer 360. You are probably aware of all of this. And we also do a lot of less critical use cases, but still useful log analysis, metrics, notification stuff. This is why, from our perspective, Kafka is really won the game, or is winning the game from this point. And when you think about it, we say Kafka, but actually, from our perspective, it's more the Kafka protocol itself. When you see all these options, below, Streamative, Red Panda, WildStream, Confluent, all amazing, partners, they are all Kafka compatible. So they understand Kafka, the protocol itself. But behind the scene, it's not Kafka. It's not Apache Kafka itself. Apache Kafka is just one implementation of the Kafka protocol, and all of them here are actually implementing the Kafka protocol, including ourselves. Conduktor Gateway, we're going to talk about it after. We are just implementing the Kafka protocol. It's like HTTP. HTTP won the game from on the web to make website and microservices. And we can think that Kafka protocol is actually winning the data streaming, is the data streaming protocol itself. Where is it going? So a lot, that the cost was massive, and it's still a massive thing to fix these days. Confluent are all evolving in this space to really nail down the cost of Kafka, because Kafka has a lot of storage. You need a lot of storage to host your data, and it just keeps growing. But then we have other, a lot of technologies about stream processing. It's super nice to have plenty of data in Kafka, but you need to process them in real time because it's more efficient often. And we see a lot of new actors coming in this space. Then you have a lot of things regarding data contracts. So some of you might be already aware of the data mesh thing. You know that Kafka is just a bunch of bytes, so it has no idea about what the data are about. And this is where the contract with the schema registry and things around all the infrastructure actually makes sense. And this is definitely an area where the ecosystem is growing. And last but not least, the analytics part. If you were at Kafka Summit, you heard that Confluent is really want to reduce the gap between the analytics estate and the operational data estate to really combine all these things. There are already a few, KIPs, Kafka improvement proposal, to have the data in Kafka, but as Parquet. This way you can connect from existing analytical system directly to the data of Kafka. Confluent announced Tableflow. It's an amazing thing, generating iceberg table. So more and more in the upcoming years, we are going clearly to see a fusion, convergence of this.
So I guess what we wanted to look at is beyond the technology and all of the improvements, all of the KIPs, all of the things that Stefan's just alluded to. We also wanted to look at kind of the things that are slowing us down. So these are a couple of statistics from the 2023 data streaming report, outlining some of the problems that people are still having with harnessing Nest technology. So you can see here that 74% of IT leaders cited fragmented projects and uncoordinated teams as being a major challenge or hurdle to their data streaming adoption. At the same time, 72% lacking relevant skills, still having expertise siloed to a few individuals inside an organization, and inconsistent use of integration methods and standards. So what this really highlights is actually the challenge are less often technical, maybe with the exception of the integration point, but actually they're related to how the organization actually implements and operates Kafka at scale as well. At the same time, the quotes from Splunk and Kenzu research obviously indicating that there are challenges not necessarily with the infrastructure and the technology, but actually the data itself, the data quality and the data reliability and how you innovate with that data. So these are some of the challenges that you have as you kind of scale Kafka inside your organization. And at the same time, another interesting thing to look at, and hopefully everybody on this call sees themselves somewhere on this schema. There's lots of different people involved with the broader Kafka ecosystem, and each of those people have different goals, they have different needs, and therefore they have different requirements. So take a look at the left side, we have a software engineer. Software engineers focused on providing value for their business, typically through building streaming applications. And to do that, an engineer needs to be well equipped to be able to troubleshoot their streaming applications, to be able to test them, to be able to monitor them, find out if things are working as correctly, and be alerted in the case of anomaly. But on the completely the other side of the spectrum, if we take a look at maybe the architect and the platform, or a platform lead, you're looking at how to implement something, align that with the business needs. So typically looking to introduce frameworks, introduce standards, and of course they therefore care about different things, data security being top of mind, data governance, and the overarching strategy that comes with that. So I guess to summarize what we're saying here is they're already leading experts to handle the Kafka infrastructure, be it managed service providers or even operators like Strimzy, which are improving the self-hosted experience. But beyond that infrastructure, it's not enough to succeed with this technology. If we look beyond the infra and we look at some of these other dimensions, so when you adopt a technology, do you have the expertise? Do you have the team with already the knowledge on operating Kafka? Kafka has a multitude of client configurations, things you can do that can be bad for other people. And are people well equipped in terms of the tooling? At the same time, you have the process aspect thing. So from a kind of ongoing BAU perspective, what does that life cycle look internally for managing Kafka resources? Are you using a GitOps approach, for example? Are you not? And what is your process for getting access to another domain's data, or for sharing your own domain data with another team? At the same time, scaling challenges like we just mentioned, so that domain ownership point. How do teams discover what data already exists inside their organization and request access to it? And then, of course, what underpins all of this is the data security challenges. So how do we meet, in Europe, the GDPR regulations? How do we meet CCPA in North America? And how do we make sure that everything that's happening in Kafka, data access, resource creation, is audited as well? And amongst all of that, Kafka is very rarely the end. It's just a piece in the overall system puzzle. And integrating with other technologies is always part of the end goal as well. So I guess with that in mind, back to you, Steph, to kind of build on that in terms of how to accelerate.
Yeah, so we are going to very quickly introduce data mesh because it's one part of where we are going to invest, Conduktor. But before this, I want to take just a step back to the history, to summarize the history in 2 minutes. James? Yeah, the next one.
Sorry.
Yeah, no worries. So we all been there, this is how IT started, just a big fat database, we know that, and a big monolith. From this, we started to, hey, let's split the whole thing and do just microservices all the way down and have a lot of peer-to-peer connection, like point-to-point to everyone. We said, okay, this is crap. Let's move to the next technology, and this is Kafka. So this is more message bus, let's say. This is how where we were or where we are even today. A lot of application, connected to Kafka. Plenty of topics like fancy topics that people are forgetting why these topics are even here. Kafka is very often connected to many SaaS to do processing, to do analytics, to do whatever we want. And we often have a data lake, data warehouse, whatever, to move the data from Kafka to something else that people in the rest of the company can actually query. I hope you all agree with this. And so from this is where people were starting to ask questions. All of this, I'm not going to enumerate all of this. You can read by yourself. But like, hey, I want to change, for instance, the sixth one. I want to change a type in my whole ecosystem. I want to change the user ID from integer to string. From my experience, this happened. We had like 2 years to do something like this. It was so messy, nobody knew. Or to the time to access a secure topic. I want to access some other data because I want to do my project. How much time today does it take? Who is involved? How many people are involved to do this? The rest, all these things are questions that, yes, data are cool. It's cool to have plenty of data, but as an organization, all these questions, someone will ask for them. And you probably don't have the best answer for all of them. And this is actually where data mesh came from. I'm going just to focus on one aspect, probably the most important one. Data are cool, but there are so much more than data, so much more. As you can see, around the data product. So a data product is really all the things around a piece of data. Data has to be trustworthy. You have to trust data. If I consume your data, I want to be sure that I can use them for business reason to take a decision. I want to know who has access, who owns this data, because if I have a problem with this data, I need to talk to someone, a human. So who owns this data? Often when you have Kafka, you have so many thousands of topics. If you do not have a system already in place, it's very, very hard to identify who owns this data. You have no idea. And the last thing is probably for me, the bottom part of that is it's cool to have data, but not all systems or all people are fluent with Kafka. If you have a legacy system, Kafka, sometimes there is no client. You need to switch to something else, HTTP or SQL. If I'm using Jupyter, to do my some analysis, I may not want to have like a Kafka consumer to consume 1 terabyte of data just to get something. So I would love to have SQL. And this is where there is this paradigm shift of, okay, we have operational data in Kafka and analytical data in some data lake to enable like SQL. But this is where also we see this convergence, because right now we have 2 silos, so 2 ownership, data pipelines in the middle. It's sometimes a nice mess, and this is actually all the things that if you want to enable data mesh, because it's a good thing, you need to think of all of this. Basically, the big idea behind data mesh is just to extract data, more value from your data. This is just the crux of the problems that we have today. Often we are very slow to deliver a new product, a new project internally, because access to the data is delicate. It takes time because the quality varies like a lot from one data set to another data set. And data mesh is just a framework to say, okay, guys, as an organization, let's think as data as a first-class citizen, and let's put some rules and some visibility around what we are doing to maximize actually the value of our data. Data mesh by itself, it's not an implementation. There is no guideline to use any kind of technology. This is just a conceptual thing. From an implementation perspective, BigQuery can be your data mesh model, can be the core of your data mesh model if you want. Trino can be that. Snowflake, dbt, Databricks, whatever. Today we are going to focus obviously on Apache Kafka. We believe it's one of the best systems to do a data mesh, to implement a data mesh model, obviously. But to do a data mesh model, you need tooling, and surprise, this is where we are.
Which is a nice segue into the Conduktor 2.0, because I think it sets the scene for where we see ourselves in the ecosystem. Essentially, we see ourselves as the platform to help connect the people and the process involved with this technology alongside the data as well. So very much building a collaborative development platform or environment for people inside the Kafka ecosystem. And we look at this in three ways, like three core dimensions. So the first one is visibility into Kafka in a secure and controlled environment. The second one is automating processes and democratizing data with Kafka Self-Serve. And the last one is how we enable new ways to secure and govern the streaming data plane. So let's dig into the first one. We're not going to dwell on this too much because I think most people hopefully are somewhat familiar with our console. But if you're not, here's a screenshot. The console is essentially our snapshot into your Kafka cluster, your Kafka Connect, your KSQL DB, your schema registry, your service accounts, everything Kafka resource related, instant visibility into what's happening now and what's happened in the past. So this is a really good tooling, obviously, to equip your software developers from a troubleshooting and debugging perspective. But at the same time, it's not enough just to give the access. How do you actually make sure that that access is governed in the right environment? And we do this through a really granular RBAC system. So if we think back to the slide that had the different actors on it, somebody in a support function requires or should potentially require a completely different set of resource and operational permissions to do their job. So from a support perspective, maybe they need to restart connectors on the weekend. Therefore, you need to be able to give that granular level of permissions to that person for them to achieve that role. The second point is around automated resource management. So this is actually just a snippet from a desired state file from our new self-service product, which is essentially declaring an application instance alongside the cluster, the service account, and the resources that are related to it. So let's dig into this one a little bit. So ultimately, what we're trying to do here is help automate and simplify the processes. So the processes for resource lifecycle, and create a better environment for a platform team and an application team to work together. Initially, we looked at this from a UI first approach last year, and actually most of the feedback we got was people want to steer this through a GitOps process. And so we've pivoted towards that. And if we look at who this benefits and the kind of how it really works, well, a platform team would essentially define the overarching rules of the game. And we do this through an application. Application is akin to a data product in terms of the data mesh paradigm. An application declares a set of resources via a prefix or a namespace, and it also declares ownership upfront through a group that would be inside the console. But the big difference between perhaps how we look at this compared to other solutions in the past is we focus on enabling a platform team to delegate the ownership to an application team. And the reason we want to do that is to help with driving a more efficient process and give that application team more autonomy. So the platform team would define an application that exists. It said, this is the namespace and you are the owner. And that application team is then free to do what they want with those resources within that application namespace. It also means that they can break down some of those boundaries from sharing data because they now have the ownership to grant access to another team, and they understand the implications of doing that. The other thing that's embedded into this is the ability to add that business metadata in those desired state files through annotations. This is obviously helping to build a bigger picture of what those resources are, what they're used for. And the advantage of Conduktor having a control plane in console means we can materialize all that metadata in the kind of application and topic inventory for you to navigate through. In terms of like the roadmap for this product, to put it in a little bit more literal sense, so we're very excited to announce the general availability of our CLI. That's coming in a release this week. And the first step really here is to be able to create that logical representation of the application inside Conduktor. It would enable you to define ownership upfront to a group that exists in console, and it will enable you to browse your application inventory inside the console. So there's a reconciliation between what's happening via the CLI and what's happening in your instance of the console. But we're aware that's only a piece of the puzzle, and we would have loved to deliver it all in March, but actually the latter pieces are going to come in April. So in April, we're going to really introduce the team collaboration and the underlying policies that you want to employ over this process. So enabling app teams to manage their own resources, grant the access to other teams, and also enable the administrators to put in place the governance rules. This is then a stepping stone to the end result, which is obviously being able to surface and utilize all of that business metadata that is defined upfront in your desired state files inside the console as well, and build new functionality on top of that. So that's what this looks like. And moving on to the third dimension.
So yeah, James, it was a very fun thing. So I have data, it scales in my organization, but there is a department called the SecOps, the security officers, the security ops. I think they are not going to be very happy about that.
Absolutely.
Right.
So what can we do to combat that?
What can you do? So when you have data, obviously we are in a world where we have to protect our data. You know how many data leaks, I think, per week we have data leaks somewhere, hacking and stuff. Obviously, there is a big part in the data mesh that to govern properly a data mesh, you have to do like encryption, data masking, and so on and so on. You have to be aware actually of the security of your data, because someone somewhere will kick to your door asking exactly for this. So if you do not think, or it's too late, you might lose your data, or something very hard will happen and you will regret it. So this is definitely an area where you have to think about it. At Conduktor, how we enable this via Kafka proxy. So most of you are probably familiar with this concept. The goal of this is to have all these security rules automatically seamlessly integrated into a middleman called gateway here. So Kafka proxy, it's totally seamless for the applications. It's totally seamless for the Kafka clusters, Red Panda, Confluent, and so on. But it gives you a lot of power. It gives you a lot of flexibility to implement things to have like a real data mesh, very secured, because this is not something you want to ask to thousands of applications. Hey guys, you have to add encryption or decryption to your data, to your application, to your Python, to your Java application, to your Spark, and so on and so on. Yeah. On top of it, so this is more a global value prop, but when we started implementing this, we realized that we can do so much more. As a middleman, we can protect your infrastructure, what we call safeguarding your Kafka. You know, Kafka has a lot of configuration flags from a client perspective. When you consume data, when you produce, it could be a fun game, but we could probably kill a Kafka clusters with misconfiguration. So obviously, as a platform team, you really want to protect yourself from this. One big aspect, as mentioned at the beginning, is the data quality. You want, if you want beautiful data, golden data in your Kafka, you really need to ensure that the quality is there. This is something that you can implement directly at the proxy level without asking your application to fix their Java or whatever. And you can implement this at a schema registry or contract level. This is really powerful. One aspect that we really love is also the virtual clusters. Let's say today, when you have a new department or you need to share data to a third party, you often need a new physical cluster. So one aspect, having a proxy, you actually set up a new tenant in this gateway, and automatically from a networking perspective, your partner can access the gateway, Kafka Conduktor gateway, access only what it needs, the data encrypted and all, and actually gateway will forward this to the real source of truth, which is actually the original Kafka clusters that you already have. I won't enumerate the rest, but if you have any request, please shoot us an email.
And if you do want to check out any of the demos of any of the proxy features, then you can find those all on our doc site, which is docs.conduktor.io.
Yeah.
Okay. Flexibility, I guess this is the summary in regards to the Kafka proxy and how it might help you. Which leads us on to the last announcement, which is, how do I get started with Conduktor? And I think this is something that we've teased. We've spoken to a lot of people. So as of today, we've expanded our free tier. And so what this really means is we want to open our free tier. We want to make most of the features accessible. And the biggest implication here is we've removed the prior limit on the number of clusters you can connect to in the free instance of console. So there is no limitation on the number of clusters now. We don't think you should be penalized for having 2 or 10 clusters. And we want to give you the basic visibility into those clusters and those resources from an exploration, a troubleshooting, and a monitoring perspective. The other change here is the introduction of SSO, acknowledging kind of the need for, if we think back to all of those different actors in the ecosystem and the fact we want to create this kind of collaborative platform where your platform team, your application developers, your architects are working together. We feel it's an important thing so that people can, start their journey, onboard their teammates, and actually work together from the beginning. And equally with user-based RBAC. If you think about security, it's often something that maybe is reserved for a mature organization, but actually we want to set the path of saying you should be thinking about security and how humans are accessing your data from the beginning. So the inclusion of a user-based RBAC model here would allow you to do that upfront, regardless of your data streaming maturity. Now, obviously, as you become a larger organization, if your data streaming needs become more mature, then we would rather be with you on your journey, and we believe you'll be in good hands, and we can support you through that journey. So if you want to get started today, you can go to conduct.io/get started. There is a one-liner command there that will bring up a Docker Compose stack with console, Red Panda, and things like that as well. So please do go check it out. And equally, if you want to deploy an instance for your team, which is the recommended way of doing this, there is scripts for Kubernetes, Helm chart, CloudFormation for AWS, and Docker as well. Very nice. Which I think leaves us on to the final point of today before we come back and answer some Q&A. So if you do have any questions, please chuck them in the chat and we'll revisit them in a second. But I will just exit my screen so I can bring up my, okay.
So we are really going to start a random thing to really show that we are not picking a name by ourselves. Good luck.
Okay, let's see. Okay, winner announced in 3, 2, 1. Okay, we have Emil at Aurori. I do not know if you're on the call already, but if you're not, we will reach out to you afterwards. And if you are, then congratulations, you've won a Nintendo Switch.
Congrats.
Thank you very much. Okay, let's just get back then to Q&A. So I don't know if there was anything you wanted to add, Stefan. Question from Luke in the chat. Are the cost components related to Conduct changing with 2.0, for example, is console separate from the other features? So I think the answer to this is no. As I said, the free tier has expanded. So there's a little bit more that you get in the free tier, but other than that, there's no changes to pricing or packaging as part of the changes that we've announced today. And some feedback on encryption with Gateway seems very interesting to test ASAP, and equally data quality. Stefan, do you want to add a point on the data quality and just in terms of how this works? I think
yes. So data quality is one of the latest developments that we did. It's a very interesting one. So you might be familiar with the Confluent data quality. So our tech is really different. Basically, you have a schema registry. Probably, I hope all of you, if you're using Kafka, you have a schema registry somewhere to govern your data schemas. We have you can go to the documentation of Conduktor. It will be clearer probably. But from in one API call, basically right now today, you can say you can add new fields to your Avro schema, for instance, embedded inside it to say, hey, this string is actually an email. This is not something that exists in Avro today, and you can just say the format of this string is email. You can say like in Avro you have integers, numbers, but often an integer can go, to minus 2000 and plus 2000 something, and in one new field to add in your Avro, you can say actually the limit, so 0 to 100, for instance, and it's instantly taken into account. And no matter the client connected to Kafka, to Gateway here, Kafka console, producer, Java, Python, Spark, whatever, they will be all dependent on this data quality, on the limitation of the data qualities that you are imposing to your Kafka. So this is really, really powerful to add
Great
to
stuff.
your ecosystem.
We have 3 questions. Let's see if we can maybe quickly get through them. So where does Gateway live? It probably has some kind of HA. Do you want to take this one?
Oh yeah, in the question.
Yes.
So Gateway. Jan, not sure. It lives. Think of it. Obviously, it's HA. Yeah. Think of it as a Kafka cluster. You can think you have a Gateway cluster. It's not exactly the same, but more or less. And about the HA, it's exactly like when you lose a Kafka broker. What happens? It's dead. My client was connected to a broker. What happens? Your client is going to retry with another broker probably because of your bootstrap servers. So this is exactly the same from a gateway perspective. If it fails, if gateway, you do something with one gateway, your client is going to retry on the next one. This is embedded in the Kafka client protocol itself. So it's totally seamless.
Awesome. And thank you, John, for chipping in as well. And then one other question we had here was around, so when will the expanded free tier be available? That's available now. So you can go over to Conduktor.io, get started, and immediately start today. And then one from Axel. So yes, I think I'm familiar with this question. So is a merge topic catalog from multiple Kafka clusters possible, or something you will add in the future? So basically having all the topics of a company in one view. I think I can take this one. I think the intention would be, as per all of the controls in console, we want to make it dynamic. We want to make it so you can customize the view to suit what your needs are. So if that is that you need to see a multi-cluster view of all the topic data, then I think that's something that we'll be considering in the future for sure. So yeah. Great. And I think that is
about Patrice performance. By default, the gateway it's really just a TCP proxy. So we accept a TCP request, we send it instantly to the broker behind. More or less, it's 2 milliseconds. According to what you are doing, obviously. If you add encryption and a lot of things, obviously you are going to pay the price according to what you do. But from a performance perspective, it's like very minimal according to in the grand scheme of things.
brilliant.
Right.
There's one more question from Daniel about multi-gateway deployments, updates. How are you applying updates to existing gateways?
You just do a rolling upgrade. It's like Kafka. Kafka, you do a rolling upgrade. Gateway, you do a rolling upgrade. All of them are connected. They are stateless, but their state is actually in Kafka itself, a bit like Kafka Connect, if you know how it works behind the scene. So you can just roll restart. It takes like almost instantly because there is no state reconciliation almost to be done. Nothing fancy really here.
Brilliant. I think that's it.
Perfect. Yeah.
Thank you everybody for joining. That was great. Like I said, you'll be redirected in a second over to the Conduktor Get Started. Look forward to working with you hopefully in the future and joining us on the next webinar. Thank you.
Thank you guys.
Goodbye.